Welcome back. We will begin solving problems related to elasticity. Question 1. An elastic material is extended by 20 centimeters when a force of 16.8 newtons is applied to it. Determine the elastic constant of the elastic material. Solution. From the question, it states that the elastic material is extended by 20 centimeters, so that is the extension or the change in length. We can say E is equal to 20 centimeters. So if you convert that to meters, you have 0.2 meters. And the force that is given in the question is 16.8 newtons. Okay, 16.8 newtons. So we are asked to find the elastic constant K. Using F is equal to KE, we know that K will be F divided by E. So the force is 16.8 newtons divided by the extension, which is 0.2 meters. 16.8 divided by 0.2 is 84 newtons per meter. So that is the elastic constant of the elastic material. Okay. All right. To the next question, it reads, a helical spring has a load of 2.2 kilograms attached to one of its free ends, which causes a change in its length. Calculate the extension of the spring if the spring constant is 550 newtons per meter. Solution. From the question, we have a helical spring that has a 2.2 kilograms load attached to one of its ends, and the spring constant is 550 newtons per meter. So we are asked to calculate the extension. K, which is the spring constant, is 550 newtons per meter. The mass that was attached was 2.2 kilograms, but we don't know the force. So force or the load will be equals to mass times gravity. Okay, so the mass is 2.2 and acceleration due to gravity is 10. That will be 22 newtons. So if F is equal to KE, I want to make E the subject of the relation or E the subject of the formula. I'll divide both sides by K, right? Therefore, E is equal to F divided by K. Therefore, E is equal to, the force is 22 newtons divided by the spring constant is 550 newtons per meter. So E will be 22 divided by 550. That will be 0.04 meters. Okay. Moving on to the next question, it reads, an elastic spring of original length 26 centimeters attains a length of 32 centimeters when a force is applied to it. If the spring constant is 460 newton per meter, calculate the force that was applied to it. Okay. Solution. The original length is 26 centimeters. So the new length was 32 centimeters. Okay. The length that is attained is going to be the new length. Okay. And the spring constant K is 460 newtons per meter. Now, If I use the formula extension is equal to new length minus original length, I will have 32 centimeters minus 26 centimeters, and that will be 6 centimeters. So if I convert that to meters, 6 centimeters, by dividing it by 100, it means the extension is 0.06 meters. The question is asking us to find the force that was applied. So force is equal to KE. What is the spring constant is 460 multiplied by the extension is 0.06. So that will be 460 times 0.06 will have 27.6 newtons. We have another problem here that reads, a spring has an original length of 16.6 centimeters. When a load of 51.2 newtons is attached to the spring, its length becomes 24.6 centimeters. Calculate, question 1, the spring constant of the spring. Question 2, the length of the spring when a load of 76.8 newtons is attached to the spring. Solution. The original length of the spring is 16.6 centimeters. The force that was applied to the spring was 51.2 newtons. And this causes a change in length, that the new length becomes 24.6 centimeters. So with this information, if this force causes the spring to attain a new length of 24.6 centimeters, then I can find the extension by saying extension is equal to new length minus the original length. The new length is 24.6 centimeters minus the original length is 16.6 centimeters. So that will give 8 centimeters. This 8 centimeters, if I convert it to meters by dividing it by 100, I'll have 0.08 meters. So answering question 1, it asks us to calculate the spring constant, which is K. We know that K is equal to F divided by E. The force was 51.2 newtons and the extension was 0.08 meters. So that will be 640 newtons per meter. Moving on to question 2, it says calculate the length of the spring when the load is 76.8 newtons. Okay? So, moving on to question 2, it says calculate the length of the spring when a load of 76.8 newton is attached to the spring. So how do we calculate that? It is asking you to calculate the new length when the load of 76.8 newton is attached to the spring. The force given or the load is 76.8 newtons, and we already know that the spring constant is 640 newtons per meter. With this, we can find the extension, right? So extension is equal to the force divided by the spring constant. So that will be 76.8 newtons divided by 640 newtons per meter. That will be 0.12 meters. But it is asking us to calculate the length, so which means that's the new length. We know that the new length is equal to the original length plus the extension. So what was the original length? The original length of the spring was 16.6 centimeters. Okay? 16.6 centimeters. If you divide by 100 to make it in meters, you'll have 0.166 meters plus the extension that we have is 0.12 meters. In that case, we'll have 0.286 meters, or it will be 28.6 centimeters if you convert it to centimeters by multiplying it by 100. Okay, and that answers the last question. Thank you very much for watching this video. If this is the first time of visiting this channel, please like, share, and do not forget to subscribe to the channel.